My name is Landon Johnson, and I'm in Calc 2000, and this is homework part 1. So the first question is a chain rule, and it's basically a rule showing how to find the derivative of like a composition or a difficult derivative. So the first rule is that the function g must be differentiable at a point called c, and then the second rule is that the function f must be differentiable at that same point c, and then the last one is that the composition f of g must be differentiable at that same point c. And so finally you can move on and then say the derivative of f of g at the point c equals f prime of g of c times g prime of c. And it's basically taking the derivative of layers of the function. So the f prime of g of c is the big part, so like the skeleton part, and then the g of c is the inside or the next part of the function. So an example would be y equals sine of 5x, and so your f of x would be sine of x and your g of x would be 5 of x. And so what you would do is by starting with the f prime of g of c, so the derivative of sine x is cosine x, and then you leave the 5x in there, and then you multiply by the derivative of g of x, which is the inside, and the derivative of 5x equals 5. So then you're left with y prime equals cosine of 5x times 5. And the second question is to find the derivative of arctangent of x. So you can write it as y equals tangent to the negative 1 of x, which is just the inverse. And so what you can do is multiply both sides by tangent. So then you'd have tangent of y equals tangent of arctangent of x. And anytime you have a function and multiply it by its inverse, they cancel each other out. So then you're left with tangent y equals x. And we're going to save this this substitution for later, so we can put that up there. So then what you can do is take the derivative of both sides. So it's basically implicit differentiation. So then the derivative of tangent y equals secant squared of y, and then you have to multiply by dy dx, which is also y prime. And then the derivative of x equals 1. So then you want to get y prime on one side, so then you divide by secant squared of y. So then you have y prime equals 1 over secant squared y. And here we can use a trig identity. So the most basic one is sine squared x plus cosine squared x equals 1. And if you divide everything by cosine, you get tangent squared x plus 1 equals secant squared x. So we can replace that secant squared y with 1 plus tangent y squared, which is what we have here. And then remember, you can substitute for the tangent y, which is up here. Tangent y equals x. So then you're left with the derivative of arctangent equals 1 over 1 plus x squared. And then the rules for finding the derivative of an inverse is that f must be differentiable at the point a, and then the derivative f prime of a cannot equal 0. And then basically if you take the derivative of an inverse, it's going to equal 1 over f prime of the inverse f of x. So a third problem is to find a rule for the derivative of a composition of 3 functions. So it's basically an extension of the chain rule. So what you want to do is keep going layer by layer. And so the big layer is f of x, and then you have the next one, which is g of h of x, and then the smallest one is h of x. So to start off, we're going to have f prime of g of h of x, which is the big part. And then you take the inside, which is g of h of x, and take that derivative. And that's like the basic chain rule formula. And then you multiply by g prime of h of x, and then finally you take the inside of that, which is h of x. So then you multiply by h prime of x. And so that's how you find the derivative of a composition of 3 fractions. And so our last problem is y equals arctangent of e to the tangent x. And this is an example of that. So your f of x is arctangent x, and then your g of x is e to the x, and then your h of x is tangent x. So what you want to do is the first layer, we just proved the derivative of arctangent and problem number 2, which is 1 over 1 plus x squared. So then what we're going to do, it's kind of like a substitution. So y prime would equal 1 over 1 plus e to the tangent x quantity squared. So your substitution, x would be e to the tangent x, so you have to square that. And then you take the next layer of this and you'd multiply by e to the tangent x. But then you have one more step because you have two functions, another composition. So then what you want to do is take that derivative, which is the derivative of tangent x, which is also secant squared x. So then here's your final answer.